Hey, welcome back. And today we're going to continue our journey to Minimax and we're going to talk about this super hard problem, cat and mouse. And we're going to go ahead and read the question. A game is played by a cat and mouse named a cat and mouse. And the environment is represented by the grid. We have the rows and columns. And where each element is a wall, floor, and we have two players, cat and mouse, or the food. And the players are represented by different characters. We have C stands for a cat, M stands for a mouse, and we have the dot period stands for the empty spaces we can walk on. And we also have the hashtag or the walls that blocking cat and mouse are from moving. So we cannot, the cat and mouse cannot cross the wall. And we have the F stands for the food. So we have cat and mouse and food and the grid, the empty spaces we can walk on, and the hashtag stands for the wall that are like blockers. The mouse and the cat can play accordingly to the following rules. So what are the rules we have? The mouse can move first, and then they take turns to move. So mouse goes first, and then cat, and then mouse. And during each turn, the cat and mouse can jump into one of the four directions: left, right, up, and down. They cannot jump over the wall, nor the outside of the grid. Cat jump, mouse jump are the maximum length that the cat and mouse can jump at a time, respectively. And cat and mouse can jump less than the maximum length that we defined within the cat jump, mouse jump. Staying in the same position is allowed, so we can jump 0 step all the way to cat jump or the mouse jump that we defined in the parameter. And mouse can jump over the cat. They cannot jump over the walls, but the mouse can jump over the cat. For example, the cat is right here, and the mouse can jump over the cat as long as the maximum jump is allowed. How will the game end? So we got 4 different ways. The first way is when the cat occupies the same position as the mouse. So cat wins. So cat catch the mouse. Cat wins. Or the cat can go ahead and directly waiting for the mouse at this spot. So that means cat is smart. Cat will directly go into the foot spot and just waiting for the mouse to come over. Or the mouse will reach the foot first, and then that's when mouse win. Or we have the last tricky condition. So this is actually a trick. So after like 1,000 turns, if the mouse cannot reach the food, then cat wins. But sometimes we have less empty spaces, but sometimes that they are running in the loop. So that's why we wanna count the empty spaces. So I'm gonna show you guys within the code. So let's go ahead and write the code, and we're gonna learn this from coding. Okay, so we can go ahead and start doing some coding. We're going to define the boundaries M and N. So we have the grid was being given. So we're going to go ahead and write rows and columns. And we're going to have a valid. It stands for how many empty spaces we have, how many empty spaces we can walk on. So we're going to loop through every single grid to calculate it. And we are going to also find the cat and mouse and also the food. Where are they? And grid I and J stands for each grid, and as long as it's not equal to the hashtag, that means we have a valid place to go. And then we're gonna loop this 4 times, and we're gonna find our cat. We're gonna find our cat, and we find a position. You know what, let's copy this over again. Perfect. So we have our cat, so we need to find the mouse as well. Mouse will be mouse, and the food will be the food. Now we have all the parameters are ready, so let's go ahead and write our helper function, which is our DFS. So the reason we made everything to tuple is because when I cache the value. So let's put the cache first. Func tools that LRU cache. So you can go ahead and write your manual cache. So we have been talking about this for a long time. So this is the Python trick to cache the values. Or you can use the hash map to cache it. So we're gonna have the mouse, we're gonna have the cat, we also have the turn. So turn means like which round, which animal should go ahead and play the game. So the mouse starts first, so that's what we give in the game. And let's write the terminated terminal condition. So when's the base case? When's the game will end? So we actually given right here. Let's just copy this over. So if the cat occupies the same position as the mouse, so if the cat equal to the mouse, or if the cat go into the spot where the foot is, then we return false. So we are acting as the player as mouse. So if the cat catch the mouse, or if the cat go into the foot spot, then the mouse lose. And this one more condition we have to be really careful. So turn will tracking like how many rounds we have been given, and if the turn is greater or equal to the valid times 2. The valid stands for how many empty spaces we can go. So if the turn go over twice as the empty spaces we have, that means we are running in the loop. Then, so the question is asking if the cat is running over 1000. So it's right here. If the mouse cannot get the foot within 1000 turns, cats win. But 1000 is not the constraint actually. It's not the stricter constraint. The stricter constraint is the valid spaces. So if we keep running in the loop, then we are eventually going to lose the game as well, because we are running in the infinite loop. So if the mouse is equal to the foot, that means the mouse will win. So that's why we're going to return true. So first round is going to be the mouse turn. Mouse goes first. So if the turn mod 2 equal to 0, that means we are in the even number, so the mouse turn. So for N stands for next. So next mouse in the next position. We put mouse in, we put the turn in. So we're gonna write a separate function, next position, to calculate where are the positions that the mouse can go. So based on the turn, we can determine if it's cat turn or the mouse turn. And based on that, we can calculate, because we are given the maximum length that the animal can jump. And based on that, we're also given the position. So we can calculate what are the next positions we can calculate. So we're gonna write the helper function. And same thing. So we're gonna write the minimax function. So then we put next mouse in and put the next cat in, and we put turn +1 because each round we +1. So if one of the round that the mouse can win, we just return true because we are the mouse. So we can win. So otherwise we just return false. So else, so this is gonna be the cat turn. And based on that, so we're gonna calculate all the positions that our cat can go. So we're gonna put the next position, and we're gonna put the cat, we're gonna put the turn, and we're gonna calculate all the positions that where the cat can go. And we're gonna put the DFS as well. Now we're gonna pass in the mouse. We're gonna have the next cat and turn +1 as well. So the opponents also play optimally. So that's why when we return false from the opponents, so we just return false because we are playing optimally, and otherwise we just return true. Perfect. So now we are finishing the function. So we can go ahead, write the helper function, next position. The next position. So we're gonna have the next position, and we're gonna put the position in. We're gonna have the turn as well. Okay, so given the position, so how many jumps we can go. So let's define the list, and we're gonna return the list as well. So the jump will be equal to so if turn mod 2 equal to 0, that means we have mouse jump, mouse goes even, else we have the cat jump. Now we have the jump number, and then we can go ahead and looping through all the neighbors, right? All the 4 positions. So we're gonna have -1, 1, 0, -1, 0, 1. Perfect. So we're gonna loop through, like exploring all the neighbors, and then we're gonna find out how many steps we can find. We can jump. So we can stay in the same spot. So that's why we're gonna go from 0 all the way to jump. So we have jump +1 because Python only allowed the exclusive. We don't include the last number. And then we're gonna calculate the next coordinate. So that's gonna be a position 0 plus the step times the dx. And same thing with the y. Will be position of 1 plus the step times dy. So we're exploring this. So as long as we are within the coordinate, then we can go. And there's one more thing. Actually, it's supposed to be and. So as long as we are within the coordinates, so we can go ahead and rolling. We can start like crawling. But one more thing, we cannot move if it's not empty spaces. So we need to check, make sure this is not a wall. So we cannot cross the wall. So that's why as long as it's not a wall, so we can move. Otherwise we break. So we're gonna continue, we'll break. Why? Because for example, if the mouse can jump like three spot, right? So for example, on the left is a wall, so the cat cannot jump over. So that's why we're gonna break instead of continue. So we're gonna break from this direction. While looping through this direction, we are checking 1 step, 2 step, 3 step. So as long as we cannot jump that far, so we break. Perfect. I think we're finished. So let's go ahead and call in the function. We put the mouse in, we put cat in, which we calculated on the very top, and see if that works. Turn. Oh, I'm actually writing the inner function, so I shouldn't need this self. We need to do some debug. Okay. Minor. Sorry. Okay, it passed. All right, so let's do a little bit recap. So what we're doing right here is that, so we are calculating the vetted, so how many empty spaces we can walk on, and we have the 3 coordinates we need to cache, and we're gonna have so we're gonna cache the vetted, otherwise it's gonna be TLE, and we're gonna have mouse, we're gonna have cat, and we have the turn. So all the conditions we calculated. So this is actually given, right? All the conditions are given except this part. So instead of like 1000, we put the vetted times 2. That means how many empty spaces we can walk on, and as long as we are passing all the empty spaces twice, that means like we are going over a loop. So as long as we are in the loop, then we return false. That means the cat cannot win because we already go over that. we're gonna go into the infinite loop. So if the mouse reach the food, and then we are return true, because the mouse already win, and the mouse can go and the cat can go. Each player play with optimal solution, and we are done. So all we does right here is the find the next position. So it's more like a BFS standard. Okay, looks great. Okay, I'll see you guys in the next video.